Let us start with next protocol of random access, that is CSMA. Full form of CSMA is Carrier Sense Multiple Access. The idea behind CSMA is before sending any information or the message, node should sense the medium, whether the medium is ideal or busy. The principle behind CSMA is listen before talk, that is, sense before transmission. You can just observe this diagram. In this diagram, we have four nodes or four stations A, B, C, and D. Over the B, we have written it as B starts at time t1, C starts at time t2. Since C starts at time t2, it fails to recognize the data of B, which is still at the transmission mode during the time t2. Thus, there is a chance of collision occurring. The meaning is B has started its transmission at time t1, C has started its transmission at the time t2, but still B's transmission does not end at the time t2. So at the time t2 there will be a collision between the data of the node C and data of the node B. Now we'll see about the vulnerable time. Vulnerable time is nothing but time period during which collision occurs. To explain the vulnerable time, you can consider the following diagram. In this diagram, just observe the things. A is transmitting at time t1. This signal takes some time to reach the node B, and B does not know at time t1 the A has started, and let us assume that B senses the medium at time t2. In the diagram you can just observe the dot. At that dot point of the B, we'll name it as time t2, and at time t2 B senses the medium. So until B senses the medium, it does not come to know about the data transmission of A. In the same manner, you can observe the dot at the node C. We'll name it as time t3. C will sense the medium at the time t3, where it fails to identify or recognize the data transmission of node A, where A is still not terminated its transmission. So there could be a collision between A data and B data at time t2, data of A and data of C at time t3. Similarly, the dot at the node D is named as t4. There can be collision between A and D at the time t4. And t2, t3, t4, we can just name them as propagation delays. Hence, vulnerable time is equal to propagation time. Now, we'll see the next topic. To avoid the collision, we have many ways. Those ways are known as persistence method. We have three persistence method: one persistent, non-persistent, and p-persistent. First, we'll study about one persistent. In one persistent, just observe the diagram. Let us assume there is one node called node A, and node A want to send a data. So what that node A will do? Before sending a data, node A will sense the medium. It will sense continuously until the medium is ideal. Once the medium is ideal, it start transmission of data. The same is explained in the following flowchart. If channel is busy, continue the sensing of medium. If the channel is ideal, then station can transmit the data. Now we'll see about the non-persistent. In non-persistent, first the node will sense the medium. If the medium is not ideal, then it will wait for some random amount of time and again sense the medium. If again the medium is not ideal, it will wait for some other random amount of time and then sends the medium. If the same thing is continued until the medium is ideal. Once the medium is ideal, it starts transmitting its data. Now we'll see the following flowchart. If the channel is busy, wait for random amount of time and then sense the channel. If the channel is ideal, channel can start the transmission. Now the third one is P persistent. You can just observe the diagram of P persistent. Initially, node will sense the medium. It will sense the medium until the medium is ideal. Once the medium is ideal, then node will not immediately start the transmission of data. Instead of immediately starting the transmission of data, it will wait for some time slot. Then, even though the medium is ideal after that time slot, then it will start its transmission. If it is not ideal, again it will wait for next time slot. The same thing is continued until the medium is ideal after the time slots. Same thing we can explain with the flowchart diagram. If the channel is ideal, then what it will do? It will calculate the probability outcome. And if the probability outcome it is less than or equal to P, then station can transmit. If it is greater than the probability, it will wait for a slot period of time and again sends the channel. If the channel is busy, then what it will do? If it is busy, then it will continue to sense the medium. This completes one second protocol of random access, that is CSMA.